Welcome to my channel. In today's video, we'll be looking at how to use Statgraphics 19 Centurion to analyze our data for shelf life analysis. Shelf life is very important in many industries: food industry, pharmaceuticals, cosmetic. All these production industries need to know how long their products can stay on the shelf or can stay in any condition that it is given. So we need scientific data to back the things we see physically to be able to tell when the product has gone bad or when the product has begun going defective. So shelf life is based on, for food samples especially, is based on the physiochemical properties, the microbiological properties, and the sensory properties. So the sensory is something that you can observe as a product developer who has made your product. So for example, if you've made a yogurt product, you know how your yogurt tastes, you know how your yogurt looks in terms of color, you know its consistency, you know its flow and things like that. So you can share it with your team and then develop a questionnaire as to their general acceptability of the product over a period of time. So that is with a sensory, the qualified sensory experts too who can do a very good sensory analysis for you. However, normally sensory analysis are a bit subjective because it's based on the individuals who taste their preferences. And there is also another way of finding out these sensory properties using equipment that will give you more of an objective um, data and not subjective this time around. So, for example, in the same yogurt product, you may be looking at how it flows with the help of the urometer or with the help of urology. You can tell the flow rate, you can tell the viscosity and things like that. That property can be given to you with the help of a urometer. Then also, we can look at other physiochemical properties like the pH, how acidic the yogurt is, and things like that. So every product has its own parameters that will help you identify whether it's going bad or not. So when you look at a product, you can research or find out what parameters normally indicate spoilage in such products. So if it's with a dairy product, maybe you can be looking at the pH. Is it going so sour? Is it going so low in terms of pH? And that will reflect in terms of the tanginess of the fuel. So your sensory will correspond to your pH values. Then also in terms of flow, urological properties will also reflect with what people say in the sensory in terms of how thick, in terms of how fluid it is with regards to flow. With regards to color, people can observe the color, how white or how dark it is. And then there is also a chromometer or some sort of equipment that you can use to determine the color of your product. So these will give you objective values that can help you estimate your shelf life. And I'm using the term carefully, estimate, because shelf life is not determined, as an accurate or as a fixed value. It's normally based on statistics, and there's a whole maths behind it. We always want to tread on a portion or on the path of safety. So uh, many a times, whatever parameter you are using, you would also want to add the microbiological data to it, because if the product looks good but it's not microbiologically safe, then it's not fit for consumption. And in many cases, um, the microbial spoilage will normally be triggered first before the physiochemical um, spoilages or spoilage parameters are seen or are measured. So your microbial counts are normally going to be the indicator for your shelf life study. But it's not always the case. It depends largely on the product because there are some products that are very stable microbiologically, but then other parameters may be lost. A typical example is oil. Oil can be very microbiologically safe because it doesn't contain a lot of water. Normally, oil, a very good oil will not have water, so the water activity is low, and because of that, microbial activity will not proliferate that much in such a sample. However, oil can go rancid, so your FFA or free fatty acid values or acid value and things like that can easily be affected. So when you are dealing with shelf life, you look at the parameter that indicates spoilage in your products, and then you find an objective means of measuring that values, and you measure it over a time period, and based on the data you gather, you are able to determine your shelf life. And I'm choosing this software, Statgraphic, carefully because Statgraphic is an application that gives you that stability study tool as part of its analysis. With the other applications, you have to use regression analysis and find the model that gives you the best R squared. We'll go more into that. The model that gives you the best R squared, and then you try and plot your own graph with the application and develop the equation, find the equation on the graph, and with your own mathematics, you compute what your shelf life will be. Now, with that graphic, you can put in your data, it will do the analysis for you and get you an estimate of your shelf life. So let's do this in Stat Graphic. First of all, we will need to load our data. I don't have any data, so this is how the platform or the interface looks like. It has a data book, a stats advisor, and things like that. So I'm going to open the data book. That's this, and enter my data. So I can decide to put the weeks here or the duration or time. It could be days, but in this case, the data set I have is in weeks, and then my sample ID can be here. Sample A1. It's a pastry snack, and the type of values I'm going to enter is numeric for both of them. So I'll just copy my data and then paste it here, and then we'll move on to the analysis itself. So the data I have here is microbial data. That's the total microbial load in a pastry snack at week 0, week 1, week 3, week 6, up to week 20. You can see from here that from week 0 to week 12, there were no significant counts. They were all 0, 0. So this could be the average of your response. So in my case, I'm using microbial data in log CFU. In your case, you can use a gram. It could be FFA values. It could be acid values. It could be pH, what have you. But for whatever parameter you use, you need to have a reference point. That is the specification limit. And in this case, going to use a reference point that has been given by Ghana Standards Authority for pastry samples, just for this demonstration. Okay, so for pastry samples should not exceed 1 times 10 to the power 4 coloniform units, aircraft, or something. In other products, they may be different. So if it should not exceed 1 times 10 to the power 4, then it means when I convert that 1 times 10 to the power 4 to log CFU units, it's going to be 4 log CFU. Those calculations could be done elsewhere. And so now we have our data, and we just head straight to the relation menu on the menu bar. And as you can see, we have under the regression ribbon, we have the simple regression model, piecewise linear regression, orthogonal regression, comparison of regression lines, polynomial regression, stability study. And we also have the multiple factors for people who are doing a number of parameters on the same product. Probably you're analyzing the microbial, you're analyzing some physiochemical properties. You can use the multiple factors for such a relation. So to make work easier for all of us and for beginners in shelf life for this particular tutorial session, I'm going to use the stability study. So I'll just hit the stability study here. And I'm going to put the weeks column on the time because it's duration. And that is my dependent variable. That's my dependent variable. It means that my response is dependent on the weeks. Then my independence will be on the y-axis. So that's the response, the log CFU. If I have batches of the same products that I'm testing, I can put those results for the second batch in this uh, slot. And the LSL is a lower specification limit. So for some samples, you would have a lower specification limit and then an upper one. But normally for shelf life, we are looking at the upper specification limits at which the product has gone bad. And so, as I mentioned earlier, for pastry products, in the context of what we are doing is 4 log CFU. So I'll put the 4 here or 4.00 and I'll go to OK. Over here, you have to identify the percentile you are choosing. And so there is also a theory behind this. Normally, in some research papers I have seen, the 90 percentile is used. So that is to say that if nothing at all, like 90% of the population should be safe in terms of your data. 10% could be given out as an error, 10% allowable error. And in terms of confidence, the confidence level in terms for statistics, normally we use either 95% or 99%. If you are using 95%, it means your alpha is 0.05. If you are using 99, your alpha is 0.01. So keep it at 95% confidence level. We are not selecting any transformation, but alternatively, you can choose transformation if you are sure of how you know your graph should be like. But for now, we are not choosing any. We'll just go to OK. Or you can decide to choose. If you want to choose, I would advise you choose the linear because for a shelf life plot, if it's done very well, you should have some sort of linear curve. But it all depends on the property of the material. Sometimes you have the actual microbial growth curve, and that looks more like a polynomial curve sometimes. So let's just leave it at none. Go to OK. So it's asking you the kind of tables you want and the kind of graphs you want. So I need the analysis summary. I need the shelf life estimate. I don't want to worry my head in finding what the shelf life actually is. So she just give me an estimation. Then this is very important. Comparison to alternative models. It's going to give you a shelf life plot. You can choose any of these if you are interested in them, but the comparison with alternative models is very important, and I'll explain that very soon. So our analysis is complete, and then here we are. Our response is given here, the time, the number of batches is one, the batch type is fixed, the number of complete cases or analysis we've done is 12 times. The model is linear. As I mentioned, normally you can choose the linear if you are not sure, and make sure the comparison has been chosen because that is what will tell you the right model to use. Now here are model coefficients, the t statistic, the p-value for a constant and weak. That's not what we are interested in. What I want us to look at now is the comparison with other models. You can see from here that the R squared for this particular linear model is 80.5396%. Now let's look at other models. The squared x is giving us 92.38%. The double squared is 90.65. The squared root y model is 89, in that order. Then for shelf life, you always want to choose a model that is going to give you an R squared closest to 100%. An R squared closest to 100%. And the reason is that it tells how well the independent variable, which is our response, the log CFU in this case, the microbial count, relates with the dependent variable, that's the time. And as we all know, when the product is being stored for a long time, the expectation is as the time is increasing, the product will also be going towards its deterioration. So the closer it is to one, it means it has a very close relationship with um, the time or the duration that you are using. And that gives you a best fit in terms of graph. And that will help you get a very good uh, estimation of your shelf life. So even though the stats graphic has given us an estimation based on the linear model, which of course you could have used Excel to plot our own linear graph and get the equation of the graph and use it to determine it. We need to know the model that works best, gives us a better R squared value, and then now change the graphs model from a linear one into the, in this case, we're going to use the squared x that has the highest R squared value into the S squared. So at this point, you can see from here the shelf life estimates. With this particular linear model, it's giving us a shelf life of 30.3509. 30.3509. And this is in the unit of your duration. So if your duration was in days, it will be 30.35 days. If your duration was in weeks, which in this case, the data was in weeks. So this is 30.35 weeks. So we can approximate it to 30 weeks. That is to say that the product has a shelf life of about 7.5 months for this particular pastry uh, product. So that's with that, and then the coefficient and things also have information they give. It talks about the strength or and the direction of the relationship between each of the independent variables if you have more and the dependent one. So it tells you if it's positive, it's telling you the direction. If it's negative, it tells you the kind of direction as time is increasing, something is reducing, and things like that. But for the purpose of this tutorial, we are interested in identifying the shelf life. So now, this is telling us that the product Yeah, this table shows that the estimated shelf life for log CFU, because I labeled it as such, equals 30.3509. The shelf life the is determined by calculating the upper 95% confidence bound for the 90th percentile of each batch and determining where the largest bound intersects with the upper specification of 4.0. So these are the explanations. And so now this advisor saying that this table shows the results of fitting several uh, curvilinear models to the data. Of the models fitted, the squared X model yields the highest R squared value of 92.3776. This is 11.838% higher than the currently selected linear model. So to change the models, we need to select the analysis options. We need to select the analysis options dialog box, and this can be located here in the input section. So I'll just head there and I'll change the model. So I'll go to an alternative model and I'll change it from linear to, notice that this is squared root of y, not squared x. This is also squared y and not squared x. Squared y is squaring your response, the y-axis. So my interest is in the square x. So I'll look for squared x, which is here. And I'll get a new model fitted for me. This is a new model. And you would realize that it reduces the shelf life, but that gives you a better estimation of the shelf life than using the linear model. So 24.7056 weeks is the shelf life for product. And you can export this data. You can export this data to, you can copy it to Word, or you can actually export it, save as, you can save the portfolio, and you can export it also to Word by copying and pasting. Select the window, and then you can copy and then paste it in your Word. Can at the same time copy this graph and then also paste it, so you can actually save it or even print it out as a PDF version also. I hope you found this video helpful. I hope that in subsequent videos I can explain how to go about working with multiple data, uh, that's dealing with more than one response, and then how that can help you determine the shelf life of a product, and then also how we can use Microsoft Excel to go about shelf life. But just before I end the video, let me just explain this so that even if you are using Excel, you can work around something. So whatever results we had, where's the results? Okay, you would realize that an equation is given for the graph. An equation is given for the graph, and this is the equation. Log CFU per gram, which is actually the y-axis, is equal to this times the weeks squared. Because remember that we changed the model from a linear graph, which is normally y is equal to mx plus c, to y is equal to mx squared plus c. We have squared the x-axis. So now that's why we have it this way. So if you plot this even in your Excel using regression analysis, you just need to get the data, the equation of the graph in Excel. Sorry, equation of the graph in Excel and now put in your upper limit, which is the 4, the specification limit, which is the 4, the response 4 here, and use it to find the number of ways the product will stay. Because all these constants tells you the property of your sample. So you can put in your value here, the limits or the reference standard, and then use that to calculate your number of weeks or your X. So that's as simple as that. If you are using Excel or any other statistical uh, package to do this kind of analysis. So I'll see you in my next video uh, when I'll do the same prediction using Microsoft Excel. See you in the next video.